right, we're going to talk about circuits, and I want to keep it kind of short, sweet, and to the point. So circuit electricity is just an expansion on our understanding of electricity out of static electricity, thinking about the flow of charge between 2 points. We actually saw that in a lot of cases in electrostatics. For example, lightning, we talked about the spark at the gas station. So all those were instances of flowing charge. And all those happened because of a large potential difference. So potential difference is our big idea here with current electricity. Why does charge flow? Well, there is a difference in potential energy, and it moves from high potential to low potential. So if you want to take notes on this stuff, this is on page 21 of our class note packet. And simple definition of current electricity is just the flow of charge due to a source of potential difference or voltage. So we need this difference. We need this voltage source. We need this energy source for our circuits to work. And that's what's happening when we have just a regular circuit like with a battery. So batteries have a positive side and a negative side. The little one with the top on your standard AA or AAA battery is the positive side. And in order for electrons to flow through a circuit, we need the potential difference. And really, if I'm an electron, sitting here at the bottom of the battery by the negative terminal, I want to get away from that negative terminal. We can think about the way the battery works as building up charge on one side. So a circuit is just a closed loop for current to flow. But again, it needs potential difference for the current to flow or the charge to flow. So this begs us to define this word current. And current we can think of in the same way as water flows. So it's just the flow of charge. So we've kind of said similar things, but that's okay. Our equation for current and the symbol for current. So first off, the symbol for current is capital I. Occasionally you'll see a lowercase I, but we're going to keep it capital I here. And it's the change in the amount of charge flowing through a circuit divided by the time that it takes for that charge to flow. This is in your reference table, so I'm going to put it in a box. So then we have to think about, okay, what are the units of current? Well, the units are units of charge, which we're thinking about the flow of a lot of electrons. It's more helpful to think about that as a coulomb, a lot of electrons, divided by time, which we measure in seconds. So it's a coulomb per second in its most base units, and that's a really useful unit to remember when you're thinking about current, flow of charge, coulomb per second. But we're also going to see that folks chose to call this the ampere, or the amp, or capital A in short. So just in its most simplest form, it's the amount of charge that passes a point in a given period of time. So if we look at the first example problem here, it says 20 coulombs of charge pass a given point in 4 seconds. What is the current? So the current is the amount of charge that flows through that point, 20 coulombs, divided by the time it took to do that, 4 seconds. So that's 5 coulombs per second, or 5 amps. The second one gets a little more complicated because it asks about the electrons. And this isn't a common question, but something that's worth talking about. So it says a wire carries a current of 20 amperes. How many coulombs of charge pass a given point in this wire in 1 second? So we could do the math, right? So we could rearrange our formula to say, okay, the change in charge is the current times time. So I'm going to take my 20 amperes and multiply by 1 second. I get 20 coulombs. But we can also just think about the fact that an ampere is a coulomb per second. So 20 amperes is 20 coulombs passing through this point every second. So the answer is 20 coulombs. So then how many electrons is that? So this is just a little bit of a conversion or dimensional analysis problem. So if I have 20 coulombs and I know that 1 coulomb is 6.25 times 10 to the 18 electrons or elementary charges, then I can easily find my current by just multiplying those two. I just got a calculator and I calculated 20 times 6.25 times 10 to the 18, and I got 1.25 times 10 to the 20 electrons. This is a large number, so you can kind of see more easily why it's nice to work in coulombs. So this is my short and sweet introduction to current electricity. Hope you liked it. Bye!